Okay, thank you everyone to be here. And this is a presentation about PDF, yeah, in 2026, but how PDF are now managed, processed in web application. I mean, until Windows 7 era, that seems to be 2 decades ago, we used to open PDF file on our operating system using a client, for example, Adobe Reader. But now we switched this to web application. This means website or mobile application that process the PDF file directly in the browser. And yeah, it was quite popular to read about PDF as attack vector for 0-day, especially 20 years ago. Now, it can still happen, but it is less common. But how the PDF are now used to hack a web application, for example. If we open this file and you see this, you see an alert. Do you think that this is a cross-site scripting vulnerability or not? No answer? OK, in this specific case, this is not a cross-site scripting. This is a feature by the PDF itself that has a sandbox to provide a basic API level to run some specific non-malicious JavaScript code. It is by design. It is supported by the PDF format. But if we open this file in this PDF reader, for example, that is written in React, we can see that we can access to the cookie. So sometimes you can bypass the sandbox system, or you can use the PDF vector in a web application to access to the DOM and to the cookie session, so to inject JavaScript code. Now we can start. OK, PDF in web application. As mentioned, PDF is very old format, 30 years old. It was created by Adobe in 1993. And it was a proprietary format initially. JavaScript was introduced by Adobe 6 years later, in 99. And it is interesting because JavaScript was adopted around the 95, 96. So just a few years later, Adobe decided to implement and support JavaScript, a quite modern programming language at that time, in a context totally different from the web, so a PDF file. Why? Probably because so we can play Doom on the PDF reader itself. In 2001, Foxy Reader was released. Foxy Reader is the main competitor, at least on, or has a desktop client reader for Adobe. It is the first big alternative to OpenPDF on your operating system. That at that time probably means Windows. In 2008, PDF became an open standard. This is a game change. I mean, now also other companies can easily create their own SDK, their own client, their own product to manipulate, to edit, to view a process PDF file. In just 2 years later, so in 2010, Google Chrome introduced the first browser-oriented or browser-native support for PDF. This means that now, on the desktop, of course, you can open your PDF file directly in your browser without downloading the PDF locally and open with a local client, local reader, or without using complex system based on third-party browser extension. Because at that time, before this feature, to open a PDF directly in your browser, you need to install an Adobe official browser extension for Chrome. You need to have Adobe Reader installed locally, and you can in some way preview the PDF file in the browser. 1 year later, in 2011, Mozilla released PDF.js. It's different from the Chrome solution because the Chrome solution is a software acquired by Foxit, software written in C++, and integrated in the Chrome browser. It is written, it's PDFium. You can run technically also as standalone software, but in general, it is used in particular by the browser or a similar solution. Mozilla decided to move in a different way. They decided to support PDF natively in the browser, but instead of using a C++ code base, like the browser code base, they decided to implement from scratch a PDF reader written totally in JavaScript. This means that now for the JavaScript reader is a web application, and it can suffer of all the web application vulnerabilities. In particular, we are talking about cross-site scripting. In 2012, PDF was a web viewer was released. PDF now rebranded in Apryse, is one of the biggest proprietary company that provide SDK to manipulate and process PDF. It's not so now in the B2C market, but it is quite popular in the B2B, especially because they provide SDK for different environments to manipulate and process PDF. And they released their first web viewer that you can run, the first almost complete web viewer that you can run directly in your web application. Just to be clear, this solution is adopted by I Love PDF, it's adopted by Small PDF, Lumen PDF, so all the most popular B2C software as a service that you can see on Google, find on Google and use to quickly process PDF probably use this SDK. In 2014, PDF is released open source, and this is a quick overview on the history of PDF file. So let's start with the first CVE that is not new. It is 6 years old, or maybe more, and it is the CVE 2008-5158. It is a cross-site scripting vulnerability in PDF.js. This is the first vulnerability found in this library. That is interesting because it is quite popular library, downloaded more than 3 million times per week from NPM, 1,000 star on GitHub, and still active project. And this is the first vulnerability that was reported to them. The vulnerability was reported by Vladimir Palant, that is a software developer, so not a security researcher, software developer that you could know because he created one of the first adblock plugin. So he knows really well how JavaScript works and how you can write in JavaScript. The issue was quite basic. So there is this PostScript calculator. There are this PostScript calculator function in PDF.js that don't properly sanitize the user input, allowing JavaScript injection. This is a classic. So you don't sanitize an untrusted input, and it is abused to inject code. It is interesting what the failure in the sanitization. So technically, the library checks if the input is an array. So if you submit something that is not an array, it is rejected. But in the array, there are items, and the PDF.js library didn't check every item. So the array should be an integer array, but in reality, you can add any sort of item. And then the item can be used to inject code. You can find some public report in HackerOne, for example, about how this vulnerability was reported or exploited in some tool like Slack. Slack is an Electron application, and it is quite common that you can find PDF.js in the Electron application, because in Electron it's not so easy to render PDF, and PDF.js is the most popular open source solution that you can have to render PDF. Let's see the error, or let's see the payload. So this is the payload. What you can see here, it is oops. this is the object. PDF, PDF standard has object as sort of, block of code. They contain information. In this case, we have a function, a domain, a range, and you can see, OK, we have an array. This is an array. But instead of having integer, we have an item that run a basic console log function. This is just a POC. And PDF.js, when process the array, eval this code running the code. Now we are in 2024. This is a new CVE, still in PDF.js, but this is interesting. OK, this means that for the first, the second vulnerability that someone found in PDF.js was 6 years later from the first one. This means that PDF.js is very solid because it's a popular library used by everyone, checked by everyone, and at the moment, it has just 2 cross-site scripting vulnerabilities. So it is a very solid technology, and Mozilla team, so the security and the development team, are doing a great job on this library. But let's see these new vulnerabilities. What the author, the reporter, wrote in their blog post was this one. So that they were surprised that this cross-site scripting vulnerability, the new one, found in PDF.js, is not related to the JavaScript support that PDF.js and other PDF viewer have. This means that the cross-site scripting is not related to the JavaScript, the embedded JavaScript support that the PDF library has. The author, the finder is Thomas Rinsma. The CVE was reported in 2024. And at that time, in March 2025, the package was downloaded 3.5 million times per week. So it is very popular. And technically, it also affected the PDF.js on Firefox. Because even if the PDF.js used by Firefox itself is the same library, but implemented in a different way in some way. What was the issue this time? Well, we have a font matrix input. Font matrix, this means array again, and that were not properly sanitized, allowing a JavaScript injection. What is interesting here is that the issue, so the cross-site scripting vulnerability, was introduced in a similar way like the previous 6-year-old vulnerability. It's again an array that was not properly sanitized. We can see here the payload, and the structure is the same. We have an object. We have, in this case, font matrix. So we know that you can exploit this cross-site scripting, creating a malicious PDF with a specific font embedded. And we can see that we have an array, and in the array, it's already, it's again injected the JavaScript code. So 2 cross-site scripting vulnerability and a similar error, an array that was not properly sanitized. So the array was checked, but the item themselves not. This is the 2024 vulnerabilities. You can see the code, and you can see how it works. In general, PDF.js can run some JavaScript code using a complex system where can eval some code according to the API of the library. In this case, the input, the malicious input from the array, it is passed as command. And in that case, it is the library itself run it as JavaScript code. But it is very interesting to see what in the 2018 the first researcher wrote directly in the repo on Bugzilla. It will send a malicious glyph. This means that technically the first reporter in 6 years before already understood and wrote to the PDF.js developer that the glyph was a weak entry point. And so 6 years later, we have a similar vulnerability based on the same same attack and same entry point. This is quite interesting because this library has just two known CVE, this one, so cross-site scripting in 2024, cross-site scripting in 2018, and so the developer are very, very good, and you can find in the repo that there are security code review for almost all the pull requests. There is threat model, there is everything, but at the same time, the CVE have a similar root cause. So it's not easy to create a PDF library, PDF SDK to process PDF. Okay, let's move to another CVE. We have at the moment see two different CVE, two cross-site scripting injection. No one is based on the JavaScript support that various PDF reader and client have. What this means? In the 99, when Adobe introduced JavaScript support to the PDF file, the idea was this one. OK, I have a lot of legacy documents with a lot of form, for example, tax form or public administration document, they need to fill out. You don't want to use a Microsoft document for that kind of documentation because you want to have something that is immutable enough, but where you can add at least some custom value. So they implement JavaScript to support this kind of operation. Automate some check, automate some control on the form, on the input data to validate the data directly in the PDF. This was the original purpose. And this means that it makes sense that you have something to validate the user input that you want to support in the PDF file. This is a different vulnerabilities that I found in Apryse Electron. Apryse is a company that provides SDK solution, different programming languages, JavaScript, different framework also, JavaScript, C++, so and so. You can run in the backend or in the client. And it's quite popular library in the B2B market to provide a client solution. Client solution, this means a library that works and process a PDF file directly in the browser, became quite popular 10 years ago for one specific reason. Running and processing file directly in the browser is definitely cheaper than run and process file in your backend. You don't need to pay for the infrastructure. You can just allow to the user to manipulate the file directly in the browser and then just save the final output. So this is why this kind of library is adopted by different vendors, Small PDF, I Love PDF, and Dropbox. When you open a PDF in Dropbox, you are using Apryse WebViewer SDK. It is quite popular to be a proprietary NPM packages because it is downloaded more than 100,000 per week on NPM. And this specific vulnerability is different from the previous that we have seen in PDF.js. It is still a cross-site script injection, of course. We are talking about PDF as vector to inject code in a web application. But this time, the entry point is not an array, is not an object that needs to be processed by the SDK, by the library, but it is the JavaScript that you embed directly in the PDF file. So Apryse is trying, I mean, one of for business reason, is try to compete with Adobe, and they try to implement all the features that you can have in your Adobe Reader installed on your local device. So they need to support JavaScript. But supporting JavaScript in a web application means that you are trying to do something that is quite difficult because you need to allow user to run arbitrary JavaScript code in a way that is safe enough, but remembering that the browser can run JavaScript code natively. OK. So they created a sandbox to try to prevent malicious JavaScript code. So the idea was this one. OK, browser can run JavaScript. I can just allow to the user to inject classic JavaScript, but I need to sandbox the JavaScript. How I can do that? Well, they decided to proceed with a JavaScript sandbox written in JavaScript itself. Let's see the payload. So I consider this one of my most elegant payload I ever wrote. It is console.println, delete window, delete confirm, delete document, and then I can run my JavaScript payload. It is interesting because here you don't have console.log. If you try to run console.println in your browser, in your web developer console in your browser, you get an error. So this is not a standard API, at least for in JavaScript supported by browser. This is an API introduced by Adobe for the JavaScript that can run in the PDF file. So what Apryse need to do is to support the official JavaScript API provided by Adobe that are similar but sometimes different from JavaScript API provided by the browsers, and map every API to the right one in the API supported by the browser. Console.println is just a console.log. But if you have a document, a PDF document that was written or designed for Adobe Reader, you don't have console.log. You have console.println. So you need to map every function to the similar function supported by the JavaScript API in the browser. This is not, this is a quote that I read on a blog post written by a Rust security researcher. You cannot be the sandbox in pure JavaScript because you can always find a way to bypass it. And it's quite, in my opinion, it's true. I still need to find a JavaScript sandbox system that cannot be bypassed. This because, because JavaScript allow you a lot of freedom, like a lot of programming languages, and it's difficult to map every function and block every function that you don't want to run. Some popular sandbox library in JavaScript are, for example, VM2. And if you open their security tab on their GitHub repo, they have 10, 12 CVE just for sandbox bypass. So writing a solid sandbox in JavaScript to block JavaScript code or to control JavaScript code is not easy. Let's see what the JavaScript, the PDF-tron library does. So, as already said, they need to map the functions. So for console, you can see now here that they map the print.ln to a function that here is obfuscated, but it is a console log. Yeah, this proprietary SDK, it is obfuscated. Do reverse is painful. It's not like PDF.js. You need to invest time on that. But here you can see that, OK, console have support .clear, .println, and .print. This is 3 APIs supported by the Adobe JavaScript API, and they are mapping these 3 API that these 3 functions that you can use in a PDF JavaScript. They are mapping them to the right one in the browser API. And this is how they decided to implement the JavaScript sandbox. It is quite basic. There is a long list, for long I mean really long list, of variables that they decide to define as undefined. So the idea is, OK, I remove all the function, all the method that I want to block by undefining them. The list is very long. You can see that they removed the global this, they remove error, they try to remove everything. But this is just a block list. And if there is something that we know in the cybersecurity, is that, okay, block lists sometimes can help, sure, but probably they can be bypassed. And this is the case, especially when you have a very long block list. They forgot to remove one specific function. If I can come back to the payload, you can see here that I use delete. So they defined the variable as undefined, but they didn't block me to delete the variable itself. So what I did was, OK, let's try to delete the variable that they defined, and then let's see if after that I delete it, the default API is restored to a browser level. So what we did here is this one. If you define a variable as undefined, but then I delete it, the browser just switched to the default one. So we can reuse them in a browser context, in a DOM context. And this is how you can inject JavaScript code in a PDF SDK library that try to support JavaScript code in the PDF itself using a JavaScript sandbox. Also, PDF.js supports JavaScript. We can see easily this. If you go here, for example, you can see an alert one. This is definitely the same alert message that you can generate using windows.alert. But it is generated by the PDF library itself. So why PDF.js is more solid than Apryse SDK, for example, from this specific perspective, so to support JavaScript in the PDF? Well, for one reason. The strategy that the PDF.js developer choose is, the design is totally different. Apryse SDK decided to try to sandbox JavaScript using JavaScript itself. PDF.js maintainers decided to sandbox JavaScript using a WASM approach. So if you check the PDF.js project, you can see that the support to JavaScript in the PDF is not made using JavaScript itself. It's not made using an eval, for example. But it is made using a WASM. So they created this WASM file where they run the JavaScript in this context. In this way, even if you find a bypass, you are still in the WASM perimeter, and you cannot access to the DOM. So worst case scenario, maybe you can break the web application, okay, but it is just a self-attack. But you cannot access to the DOM. This means that you cannot have access to the cookies or the local storage. And this is the approach that PDF.js choose for this. This is not the only library. Also, for example, Nutrient, it's a European startup companies now that provide a web-oriented PDF SDK, so to manipulate and process PDF in the browser. And they did a similar choice. The application entirely in WASM, and the support to JavaScript is a WASM inside the WASM to prevent access to the DOM. And this is why you cannot easily exploit PDF SDK that have this kind of solution, so WASM, to sandbox the JavaScript. You can still try to access to to inject PDF JavaScript code using other vector, other object in the PDF, but not JavaScript itself. And here we can see another cross-site scripting vulnerability, still in Apryse, but where JavaScript is not involved. So JavaScript embedded in the PDF is not involved. So what we have here is just an unsanitized input injected using a weak inner HTML function that allow arbitrary JavaScript execution. Apryse, but also PDF.js and more or less every SDK that need to run in the client, in general recommend a content security policy to mitigate the risk of cross-site scripting. And if you open Dropbox and you check their PDF, online PDF reader, you can see that there is a content security policy. The content security policy was this one. OK, it is defined as meta tag. And this means that they cannot add the directive report to. They cannot collect report because the content security policy in meta tag work well, but you cannot collect data. So you don't know which kind of error you have. This is why, in general, it is recommended to use content security policy sent via header, because you can add, for example, report sample, report to collect information about the error. But if you are in the context of of a single page application, it's not always so easy, maybe, to implement an header. And so you can use just a meta tag. And this security policy is quite basic. So it's allow self-scripts. But in particular, it's allow unsafe align. Unsafe align means that you can run everything, more or less. But there is not unsafe eval. This means that if I have a JavaScript that's, I mean, a cross-site scripting injection that is based on a eval function where I can inject my strings, I cannot use it. And the Apryse JavaScript sandbox work exactly in this way. They create the JavaScript sandbox with a lot of variables that are undefined. They add your JavaScript code, and they then run just an eval to run the entire JavaScript in your browser. So in this case, I cannot use the first CVE that I show you in this talk because it was based on eval. So I was able to bypass the list of undefined variable. I was able to inject my code, and then there was an eval function that ran the code. So what we can do here? Well, we need to find a new way to inject JavaScript in the Apryse SDK library without using, without finding a vulnerability that use eval. So we move. Sorry. So what I did here, I tried to find an input that wasn't sanitized, and I tried to check if somewhere it was processed. So my approach was not try to reverse the library because it was obfuscated. It's quite too much time. The SDK library is very, very big. I just tried, a fuzzing approach. So I have some PDF for test purpose where I inject a different payload. And I've seen that one of these PDF can run code. How? Well, we have an annotation, still an object. Yeah, of course. This is an annotation. And you can see here that a rectangle is defined. It's a square, more or less. No, it's not a square. But yeah, so what is this? It is just a form. This object, it is a form. And this form has a default value. This means that for a PDF file that has a form, you can have a form where the user can type their own value. You can use JavaScript to check if the value has the right format, for example, if it is a date or whatever. But you can also add the default value for any reason. For example, if it is a Boolean form with true or false, maybe you want to have a default value. In this case, my default value was a HTML code. And the application just ran it due to an unsafe inner HTML. So they didn't sanitize the default value of the form of the annotation embedded in the PDF. This cross-site scripting doesn't use eval. This means that we can bypass the CSP because unsafe inline is allowed. This means that that code can run. And this is how I was able to run cross-site scripting on the Dropbox application. But there is a but, of course. Not yet. I was able to run JavaScript on Dropbox, but it was in iframe, and it was in a subdomain where there were no cookie session or important information in the local storage. This means that Dropbox security team they add the content security policies to mitigate the risk, but they also run the entire PDF viewer application in a total different subdomain, and they communicate with the main application using post message. This mitigates the risk. You need to find also a vulnerability in the post message if there is a vulnerability in the post message implementation. This means that they added so many layers that show me what means to create and deploy a secure application, honestly. So even if I found a cross-site scripting, even if I was able to run JavaScript inside the official Dropbox PDF viewer, I was not able to exploit it because I haven't access to didn't have access to the DOM. OK, another proper use case for PDF library are Electron application. Electron application are designed often like a web application, but that you can run locally using the Electron framework. This means that if you want to provide a PDF viewer or in-app support editor, for example, for annotation, for whatever, you need to find a solution that can run there. And in general, this means PDF.js. As said before, PDF.js is the most popular open source library. And almost all the, until 2 years ago at least, because now in Electron you can run also PDF, but until 2 years ago, to visualize and manipulate a PDF in-app in an Electron app, you probably use PDF.js. This is how a researcher in 2020 found a vulnerability in Slack, abusing an outdated version of PDF.js. And this is how this remote code execution works in Logstack. Logstack is a popular application. It's an open source application, 1,000 stars on GitHub. It's a sort of alternative to Obsidian, but open source. And they support natively PDF in their application using PDF.js. And this means that if the PDF.js version is vulnerable, maybe we can run a cross-site scripting. This is enough to reach to have a remote code execution? No. But it is a good entry point in an Electron application. So we use the PDF file as initial vector to inject JavaScript code. And after that, we have JavaScript code if we are lucky, or if we are lucky and if the application has additional vulnerability, we can escalate it. For example, in this specific case, in this specific case, the application had a complex API system inside the Electron app to run, for example, shell command. And you can use the JavaScript code to communicate with the Logstack API to run arbitrary command. We can see it. Let's see. This is a demo. This is just for the applause, for the claps. So let's see if it works. My first time. And it's worked. OK. We have the calculator. What happened here? The PDF file that is uploaded as asset in the application, it is open directly in the application using PDF.js. PDF.js, in this case, is a vulnerable version. You run JavaScript code, and then you can send API call directly to the log.js main JavaScript. In this way, we can run a GitHub command that we can use to run arbitrary code, because you can use not a GitHub command, sorry, Git command, and you can use Git to run arbitrary code, because Git is a command line tool, and in some way they offer this feature. Let's see. Okay. Okay. So we have seen 4 different cross-site scripting vulnerabilities, all reported in the 2024. So, I mean, 1 in 2018 and 3 in 2024. So quite recent vulnerability in 2 PDF JavaScript libraries. But if you try to search in the CVE database, how many cross-site scripting related to PDF there are? Well, there are many. But you can see that in 2020, Deloitte shared a CVE based on a cross-site scripting due to using PDF. He's designed a cross-site scripting report to an open source project. This is a cross-site scripting in Zimbra collaboration using a PDF file. And this is a list of CVE that I found, but there are more. And you know how many of them are real security issue? 0. All these CVE are false positive. In some way, for a lot of reasons, because people don't know maybe enough well how PDF work, or they don't know how PDF library render and process PDF. But just because too often the POC is just this one, this seems to be an alert. This seems to be a cross-site scripting. How you do send when you send a report to a security team to provide a cross-site scripting payload? It's quite common that you send window.alert, one window.alert cross XSS or something similar, because this is the proof of concept that I can run JavaScript where I should not be able. But it's not enough. For PDF, this is not true. You can easily run an alert. If we open this PDF file in, let's see if I have it. If we open this PDF file in an editor, one second, I want to show you. Okay. If we open this file, thank you, Viscode, we can find the payload. And it is just app.alert1. This means nothing. I mean, there is nothing critical in this. You cannot access the DOM. You cannot send a post request just because PDF.js doesn't support this kind of feature. This means that you can pop up a message and just that. This means that a proof of concept in a PDF, in a cross-site scripting based on PDF, cannot be just app.alert.com. If we open another file, I need to find another file. Oh yeah, I have one. If we open the payload for log4sec, for example, no. We can see that this is the payload. It's not a common app.alert, but it is a payload that is used in the context of logsec. You can see that we use logsec.sdk.git to execute a custom command to open a calculator. And this is why this is a vulnerability. But it's very common and stressful if you are a triage engineer, receiving a ton of vulnerabilities from researchers that say, oh, my PDF is opened in your domain, and there is an alert one, so you have a cross-site scripting. No, you don't have in most of the scenarios. So some recommendation for bug bounty hunters: understand the context where the PDF is rendered, because often the PDF is not rendered in the web application. It's rendered by your browser. So if you have example.com/sample.pdf and you open in Chrome or in Firefox, it's not the web application that opens the document, even if you have an alert one. It is the browser that renders the PDF using PDF or PDF.js, according if you are using Chrome or Firefox, similar for Safari. So it's not a bug in the web application, and it's not definitely a vulnerability in your browser. And app.alert1, that is the common payload used in a lot of PDF file, is not enough. It is a good starting point to understand if a specific web application support the native Adobe JavaScript API, but it's not enough to understand if the application is vulnerable or not. You should try some unsupported API by Adobe to see if you can run them. For example, if you can run, instead of app.alert, you can run window.alert, maybe you have access to the DOM. And for bug bounty manager, or people that need to triage this kind of report, that means also often open source maintainer, well, the first thing you need to understand is the context, again, because if you receive a report that you have a cross-site scripting in your PDF rendering implementation, but you have never implemented a PDF render in your application, how you can have a cross-site scripting? I mean, where is the vulnerable code? You don't have it. And the second one is ask for the impact. I mean, maybe the initial payload can be a basic window.alert, but if it can be not so easy sometimes to understand the impact of vulnerability, even if you have a cross-site scripting. So, because a JavaScript injection can run maybe in a sandbox domain, in an iframe, sandbox iframe, and so and so. So try to ask to the researcher to send a more advanced payload, a proof of concept that they can, for example, steal or print the JWT token or whatever. In this way, you can prioritize better or triage better the vulnerabilities. And how we can mitigate the cross-site scripting vulnerabilities that could be introduced by a PDF viewer better. How we can check the user input without technically scanning the PDF file, because in general you can sanitize the user input, but sanitizing a PDF is definitely more complex. Well, you can try to add a different layer to mitigate the risk. The first one is a strict and solid content security policy. Using a content security policy that implement hash plus strict dynamic, mitigate all the previous CVE that we have seen. You have still a vulnerable component for sure, but even if the researcher use a valid payload, they cannot see the output because it's blocked by the content security policy. They can still see that it is the content security policy that blocked them. So technically the code is vulnerable, but the application is still safe. And this gives you time to mitigate the issue to code level. For example, uploading the PDF library or find another way to sanitize. Then use an isolated domain. If you need to load untrusted PDF file, it's better to run the viewer in a subdomain where there is no user session. You can use post message to communicate with the main application. And the last one is disable embedded JavaScript support. I mean, I don't know if this is a real mitigation, because we have seen that you can use, 3 out of 4 the vulnerabilities that we have seen in this presentation don't use the embedded JavaScript PDF API to inject malicious code. So, but if you don't need these, you can just disable, just in case. And thank you. This was the last slide. I hope you enjoyed this. Any question? Any software developer here? One, two, oh. Any web application software developer? OK. And have you never worked with PDF file to offer a PDF viewer in your application? Or yes?
Yeah, we used a viewer in our well, we used to use PDF to like rename, and we did hit quite a few issues. And there was like kind of like there's just an option to turn off JavaScript. Well, a lot of our forms, what we fill in online, have calculations which are based on JavaScript.
Exactly.
So you enter like the amounts for like lots of different like things, and then it recalculates the bot based on your tax and stuff like that.
Yeah.
But yeah, there's like quite a few issues to be fair.
Yeah.
Or they disable something because it was a vulnerability, and it broke out like
Yeah. This is the main reason why JavaScript exists in PDF calculation. I mean, be able to do some in the form. And yeah, Apryse in the last 5 years collected some CVE. They don't like to share vulnerabilities, unfortunately. And but yeah. Well, I hope you enjoyed this. No other question? Cool. Thank you again, and see you around.